So this is going to be a review of some SOK 314 amp hour batteries that I bought for my main ship trawler. The reason I went with these is because of the 800 amp surge capacity these things have. With two of them in parallel, I should be able to do 1600 amps, which should be able to power my bow and stern thrusters simultaneously, even though I don't really ever use both of them at the same time. I usually use the front bow thruster or the stern bow thruster, or the bow or the stern thruster one at a time, which pulls 600, 700 amps. So it should be around 350 per battery pulling out, which is more than enough considering the 800 amp surge in here. So anyway, I went ahead and mounted them in my engine room. It gave me some extra space where I could mount a toolbox down here on the shelf now, because I turned these sideways. They're secured in place with 4 bolts on each side with the brackets they have. So I've got 2 of them in here. I shortened the battery cables up from what I had before. They're both the same length going to the battery switches. One's on the A side, one's on the B side. Normally I leave them on both, so they're in parallel. Shorten the negative leads, so they're both the same. These are all in 4-aught cable, nice secured, big 4 amp connectors, heat shrinked and siliconed in place. So my name is Mike Walls. I'm retired. Spent 30 years or so in electronics. Did original electronics training in the Army, and then worked for varying medical systems, repairing medical linear accelerators, doing first field service work and then remote service work for 25 years altogether with the company, and I'm now retired. I have a main ship 34 trawler. I have a bow and stern thruster, which is why I try to go with these batteries to see how they perform. It's been working good as the thrusters, but this video is not a review about the thrusters and the performance on that. This is going to be with the balance issues I have with these batteries. These batteries are about $1,000 a piece. I think I got them a little cheaper on Amazon just because it was, it's cheaper to order from Amazon than it was to order directly from SOK's website. So I ordered through Amazon. I got these 2 batteries. The issue I'm having is these are $1,000 batteries. This is $2,000 right behind me. And I'm having an issue with one of them not being balanced. The one is balanced fine, less than 15, 20 millivolts is fine for me as far as balancing goes. But the other one, I'm not able to get up to charge to the proper voltage without it going into one of the cells, hitting 3.8 volts and going into over voltage protection mode and shutting it off. The issue is when one of the batteries does that, it shuts off the charging CMOS for that battery and lets the other battery keep charging. But when I turn them back on, or when I turn the charger off and start to discharge these batteries, it's only pulling power from one battery. The one that was in the overcurrent or over voltage protection mode is not draining back down. So it'll be stuck at 13.7, 13.8 volts when the other one will drop down to 13.2 volts. And that's pulling about 10, 11 amps of power. The only way I'm able to get the other battery to start discharging again is when I pull a high load off of it. Basically turning on my bow thrusters, pulling 300 amps out of the thing. Then it wakes it back up. And then what'll happen is one battery, the battery that was at 13.7 volts, will start discharging into this one. So then I'll have 30 amps coming out of this one and 20 amps going on into this one with the charger going off. Eventually they will find balance and equal out, but I want both of those batteries to be available. I don't want the thing to go into over current or over voltage protection every time I charge my batteries back up. I have not been able to find a way to get this battery to balance. It's just not. Everything I've tried with my profiles, I'll raise it up to. I started with a profile of 14.2 volts. The factory for my charger, it's the lithium ion profile for that. It's the lowest voltage profile I have. One of them says 13.4, the other says 14.4, the other one says 14.2. So I'm using the lower profile on that. I tried charging it up. It keeps shutting this one off into over voltage protection every single time. This one balances fine, gets up to 14.2. This one won't. I tried using a DC to DC charger, going to 13.5, 13.6 volts on this. Let the thing sit pretty much overnight to try to get these to balance back out. I did have it where it said this one was balanced. It was in normal mode at 13.58, 13.6 volt. This one would say it's balancing, but literally an hour goes by and I might see 2-3 millivolts difference over a whole hour. That's, if it does have a balancer, it's very, very slow. I tried changing the profile on my main battery charger to 14 volts. Tried charging them up again. This time, now with my main battery charger set to 14 volts, this one is no longer going into over voltage protection. It's still going too high in my opinion. It's getting up, one of the cells is going up to 3.65. Normally 3.65 would be a high charge limit where I would shut off charging on the other batteries I have. But this one, it's programmed for 3.8. But at least with it at 14, it's not going to overcurrent protection. And then the batteries are not, that over voltage protection, and it's not shutting off, and it's not causing this one to drain down, this one to stay there, and all that imbalance issue between the two batteries. The two batteries are now staying pretty close to each other, but my other batteries that I have on my boat, I've got a EG4 48 volt battery for my dinghy that it charges within 2 or 3 millivolts of each cell when it's top balanced and when it's charged up, and even when it's running, it's always been, I'd say, less than 5 millivolts between the cells. My large housemate battery that I built has 16 Eve cells, and I've got a rec BMS on there. It has a passive balancer too. Once you get up to that, start at 3.5 volts. I can program that one. I can go in and program what voltage I want the balancer to start on, and that thing perfectly balances, literally within like 1 or 2 millivolts. When I get it top balanced at 3.5 volts, it'll be 3.501, 3.502 across all 16 cells. This one, these two batteries, I don't know what to do to get them to balance. It's acting like the balancer's not working at all. But the way they've got this set up, they need to do something with the programming of these, because they're not balancing, as far as I can tell. And it's a shame that I spent $2,000 on batteries and one of them's not balanced. I mean, you're spending $1,000 on a battery. It should be balanced when you get it. You shouldn't have to top balance it. I've wasted a week of my time trying to get this thing to balance. It's very frustrating. But I've got more details if you want to watch all the details. It's about 30 minutes worth of stuff I've documented, but it's frustrating. Not happy with these batteries at all at this point. Well, it's been a few days and I've kept trying to balance these this SOK battery, the one that keeps going into over voltage protection once it gets to the end of charging. I think I finally found the right voltage. I wasn't able to do that with my larger battery charger that can charge up to 3 batteries. Using the profile it had, the voltage was just going too high. So what I've done is I've turned that off, and I'm just using a 48 volt to 12 volt Victron DC to DC charger. It can do 30 amps max. So into 2 batteries, that would be 15 amps max per battery. And I'm able to just turn a potentiometer on there to increase the voltage. And I've slowly gone up to a point where I think I've got it to where it'll keep this in balance mode and hopefully balance out. You can see here now the status says it's in balance mode, even though we're at 100% state of charge, but we're at 13.5 3.54 volts. I'm not quite maxed out on the capacity. It's at 327 out of 329, but my charge and discharge CMOSs are still on. My low cells 3340 and the high cells 3342, so basically a tenth of a volt or 102 millivolts. Again, this battery's in balance at 100% state of charge, zero current going in, and it's balancing. If I go to the other battery, it's in status normal, so it is not. Forgot how to get back to it. The other battery was in normal state, down here at 3.57 volts. So this one, we're at 34, 3387. So we've got roughly, I guess, the 4303. So we got 13 and so we're within 16 millivolts on this one. So this one is balanced, I would say. But this one says there's still 2 amps left, but this one's not in balance mode because it's within like 16 millivolts. Says normal. This one's in balance because there is, 102 millivolts difference between the two. But 13.56 seems to be the number, 13.54. We'll see if these numbers come down, these numbers come up. Hopefully we can get them to be around what the others are at 3.8, 3.38, or 3400. So I think the balance is maybe stops at 3400. I'm not 100% sure on this, but it's now 2 a.m. Since I got this in a balance state, we'll check this in the morning in like 4 hours, but it's already been on here. About 9:30 is when I went to bed and had it in this mode. It was kind of cycling between balance and not balancing. I can turn on certain things. Like right now, I just turned them over, headlights. Those are still halogen on our regular incandescent ones on this boat. And we're in discharge again. So you got to balance it. If you're discharging 1 amp, you're in normal. Turn off my halogen lights, I'm back in balance. So it is very tricky to keep this battery in balance mode. It has to have a slow charge going in. Even though it says 0 up here, you have to have a charge going in. If you are negative on there in any way, it'll drop it out of balance mode. So anyway, that's where we're at. Right now I've got the bilge lights on. I think maybe if I take them off, it might go too high. I don't want to mess with it since I've got it in this balance mode. But so it's about an hour later. It's 3:21 a.m. at this point. I'm still in balance mode. Still 13.54 volts. And 3340, 3439. So we're now at, what would that be? 99? No, we're one less. Yeah, 99 millivolts difference. So I forgot what we said before, 102, 103. It's literally moved only 3 millivolts in an hour. Very, very slow balancing, if that's what you call balancing. I'm going to go ahead and try to turn on my other charger and see what happens here. So turning on the normal battery charger switch, which is set on the lithium profile. Our current should go up here. Then we got 19 amps going in. Still in this balance mode. This voltage should start climbing. Our low one's at 3346, our high one's at 3467, so we're back up to 120 something millivolts difference. Still in balance mode. Let's go look at the other battery and see what it's doing. This one's in balance mode, 13.98, but these voltages are a lot closer. 3464 is the low, 3542 is the highest, so less than 100 between these two. And we did hit 14 volts over here. Go back to our battery over here. This one says charge complete now. So when it hits 14 volts, it says charge complete. This is the first time I've been able to hit 14 volts, but I'm looking at 3354, 33700, so that's 350 something difference. So at 14 volts, this one's probably going to go into overcurrent mode again. Alright, it's 3.88 or 3.8. That should turn the charging CMOS off up here. Hasn't yet hit 3801. Now turn the CMOS charging off. So at this point we're 14.1 volts on this cell, our battery. The other one over here, we're 14.1. This one's still taking 2 amps. Again, we're hitting 3.5 volts on all these cells. This one is balancing nicely and we'll hit 14.2 volts. Yeah, so charge complete. Charge complete. This one's not in over current protect mode, hitting 14.2, close enough, pretty much. This one, our charging CMOS is off. So it's slowly starting to drift back down. I'm going to go ahead and shut off the charger. All right, it's now 9:03 a.m. This is the battery that showed charge complete and went into that over voltage protect on that cell. You can see here it's reading 13.74 volts. It says charge complete. The charge CMOS is off. Discharge CMOS says it's on. We're at 329, 329. This cell that it had reached 3.8 is down to 3.54. Again, cell 1 is at 3.34, so we've got about 200 millivolts difference between those two. The other battery is down to 13.29, and the current is 4 amps going out of it. Status is normal. This one is now down about 10 amps in capacity, and the voltages have settled down to 3.24 to 3.27. So very well balanced on this one, 3 millivolts difference, but all the power is coming from this battery. So we got 13.2 voltage, 13.29 volts on here. The other one says it's 13.74. Now, actually at the batteries, when I do some measurements, all right, this battery reading 13.25. This one is also reading 13.24. So they're within 1 millivolt down here. So that 13.74 is measured internally in that battery on the CMOS somewhere. This one still says the CMOS charging is off, but it still says discharge is on. But it's not allowing any discharge out of that battery. And what has happened is all the power that I'm using, the 4 amps is coming out of this battery. So I'm going to have my wife turn on some more things upstairs to see if we can get this other battery to wake up. Anita, could you go turn on the water?
The faucet?
Yes, turn on the water faucet.
In the kitchen?
Yes. So when we do that, it's going to pull more current here. And I'm going to also use the current meter here to kind of show what's going on here. So now we're pulling 11 amps, right? The other battery, still nothing. So turn it back on, please. Anita, turn it back on. Oh, all the power is coming out of this battery, 10 amps. Nothing is coming out of this one. Right. So this one that you can turn it off now. So all the power is coming out of, it's not coming out of this battery at all. It says its discharge is on, but the power is not coming out of it. All the power comes out of this battery. So we're down to 13.29 volts. All right, let's try to wake it up by turning on the bow thruster. Yeah, turn it on and push it for like 3 seconds. So now we're going to wake it up by trying to pull some heavy current out of it. All right, there's a little delayed spike, but all right, thank you. now we've woken up the other one. So now that the higher voltage battery has been woken up, it turned the charge CMOS back on because the voltage is low. But now what's happening is that this one has the higher voltage, 13.49. We have 32 amps or 31 amps of current going out of this battery and into this battery. So that something's not right with that switching on and off. You have to really pull a lot of current from that thing to get that battery to start discharging. And then what happens is it'll take a while for these voltages to equal out. So this one's at 13.36 and it's got 24 amps going in. This one's at 13.47, has 27 amps going out. Eventually they will balance back up, but it shouldn't be doing that. That discharge CMOS is not really allowing discharge unless you really pull a lot of current from this thing and waking it up. 12 to 15 amps of current is not waking it up, pulling out of these batteries. It's been a few hours now, and the battery that was in over voltage protect mode is still dropping out about 3 amps. Again, you see here they've kind of leveled off. 3333, 3362. It's down within about 30 millivolts at this point, but this one's discharging 3 amps. It's at 13.37 volts. The other battery is 3.42 and discharging 1. So they're both discharging a little now. So they've kind of leveled off between the two. This one, 3346, 3348, 3348, 3351. So real nice balance on this one, 5 millivolts between the top and bottom cell. Really good balance on this battery. So it's since I go into over voltage mode on that one battery hitting 3.8 volts, I'm going to try a different charge profile on my charger. This is the charger I have, ProCharger Ultra. I was using the lower voltage. There's two different profiles here. I was not using the 14.4 on the lithium. I was using the 14.2, but I've now reprogrammed it down to a 14 volt max high charge voltage, and then float at 13.7. It's a gel lead acid profile instead of the lithium, but hopefully that lower voltage will let this thing go into float / balance mode here, and hopefully it won't do that over voltage and protect mode. All right, well, I missed the peak charging with the set at the gel setting where it hits to 14 volts here. It dropped back down to 13.7 for a little bit, and I guess now it's dropping back down to 13.2. We didn't hit the overcharge. We got up to around 3.65 volts. That's still pretty high. Most manufacturers would set that as the high cell limit. This one's at 3.8. But anyway, it got up to about 3.65. Did not shut off. Did reach 14 volts. Once it reached 14 volts, the charger shut off. It has been slowly discharging back down at about 2 amps. As far as I know, it never switched. I mean, it was on balance mode for a little bit when it was charging, but again, we're at 337, 3484, so 150 millivolts or so difference. Didn't really do any balancing on this. 13.62. The other battery, again, this one's the one that's closer in balance, 3404 to 3422, so 16, 17, 18 millivolts difference in there. This is the one that's always been pretty decent balance. It's not as good as what I'm used to seeing on my other batteries that I have. But I guess we'll just try cycling this a few times and see if it'll balance. But it's been over a week now that I've been dealing with this thing, trying to get this battery to balance. It's pretty frustrating that you spend $2,000 on some batteries and then one of them's not balanced right and keeps going into that over voltage protection mode. I'm gonna have to, I guess this one I've got set here, I'm gonna have 3 different charging sources. So I will have a 12 volt DC to DC charger that I'm gonna have to program to a lower voltage. I guess 14 volts is the max I'm gonna be able to go on this. This one I'm gonna have to leave on the gel setting for now, since I can't, if I go to 14.2, it goes to that over voltage. And then my 48 volt DC to DC, right now I've got it set at about 13.58 volts per cell, or 13.58 volts together. So it was kind of doing imbalancing and stuck at that mode. I might just turn off this charger and leave that DC to DC one on, since it was stuck in balancing mode. But again, that 1 hour period that I had it stuck in balancing mode, it only moved 3 millivolts in an hour. I guess at this point, at least it was balancing there. So I'll go back to that point at this point and leave it at that 3.5, 3.6 volt with that DC to DC on, because it was balancing very slowly, but it was balancing. This is showing what a properly balanced battery should look like. This battery's I built about a year and a half ago. It's a 16 EVE 280 amp hour cells. I've got DVCC set to 56 volts, so it doesn't charge all the way up, but it is at 99% this morning. If we look at the rec battery and look at the details, you'll see the high and low cells. 3.502. So they are perfectly balanced. Maybe right there's 1 millivolt difference between cells at the top of the range there. So perfectly top balanced, cycling between the different cells as which one's high and low, but most of the time they're 3.501 or 3.502. Well, I've got it back on just the 48 volt to 12 volt DC charger. I didn't make any adjustments to the potentiometer. Last night we were getting like 13.5, 13.6 volts, somewhere around that range. And it was in balance mode. Today I'm at 13.44 and have that one battery in balance mode. It's very tricky to keep it in balance mode with this. It depends on loads in the building or on the boat. Basically, my wife would go in and turn on the bedroom lights, and all of a sudden it's discharging again. So what I've done now is I've turned off the switch to the DC fridge and turning it on AC fridge, so it'll run off of AC power instead of DC power. So I'm back down to where I got a little bit of current going into this thing, and it shows it's balancing. I've got low cell 3331, high cell 3400, so 71 millivolts here. But again, we're not at the end peak charging current where it ramps up. So we're at 13.4 and we've still got 70 millivolts difference in here. But I guess I'll try leaving it in this mode to see if we get closer than 70 millivolts. If hopefully this number will go down over the next day or so. For now, I'll just give it time. If it does only go 2 to 3 millivolts in an hour, I mean, it's going to take 24 hours to get it down that 70 millivolts at this level, but we'll see if it'll get there. Well, after changing it to different voltages, I kind of reached a plateau where I couldn't get this thing to balance anymore. So I reached out to SOK, asked them what voltage they recommended. What would be a good voltage to stay set at and charged, and they came back and said 13.8. I was like, well, at 13.8 it goes to complete and won't stay in balance mode, and it doesn't seem to make any progress. They're like, or set it to 14.4. Well, I tried setting it to 14.4. A few minutes later, this thing hits over voltage protection, disconnects again. I've got 445 millivolts difference between there. They say, yep, that's too high. And I was like, I sent them a screenshot, sent them the serial number, my email address, and then I told them, well, it's also not discharging the way it should when it goes into overprotection mode. They say, no worry. Normally it will slowly top balance after a while. Our top support will contact you later, right? And they basically told me that the reason for the difference, and they do explain that, you get at the end of the voltage curve, and that's where they all spike up. But I've got plenty of capacity, which is true. My capacity is excellent, blah, blah, blah. Please refer to charging curve below. No need to worry, just keep using it, it'll be fine. So that's SOK's answer. It's been a couple of days now. I've been trying to keep balancing this thing. This morning I'm at I've got my charger set to 13.7, 3342, 3493. That's basically no progress in days now. Let's see, go back. It's no difference really in 24 hours it's been 2 weeks. I'll be honest, I've been messing with this thing. I still can't get it to balance. I don't like the way that Discharge does, but I've got all my chargers set to 13.7 volts now. But if you're looking at buying batteries, you need the high discharge, yeah, these would be a good choice. But if you don't need the high discharge, I'd stay away from these. The balancer just stinks on these things, and the way it discharges when you go to over voltage protect is crazy.